Welcome back to AP Statistics with Mr. Walton. Today we're going to do a little brief review for Chapter 10. So what we want to start with right here, target pieces of information and concepts that we want to make sure that we understand and can apply, whether it's in a test or with an interval or what goes with what. So this is for you. You might want to print this out. You might want to look at it and say, yes, I know this, or no, I don't, and then we'll move on. Okay, here we go. Some practice multiple choice. So let's walk through this. What's given is 1.980 is a z-score. Well, if that's my z-score, how do I use it using my hypotheses so that I can make a decision? Well, what we're going to do is, if you guys recall, just like on the quiz, is we're going to say, and that is, if you recall, normal CDF calculation, 1.980 comma infinity comma 0 comma 1. Now also remember that depends. Also, if you forget to use your calculator, you may use your green sheet and use the table of z-scores, and you could find the p-value that way as well. And this should give you 0.024, which means when I compare it to an alpha level of 0.05, I should reject H sub O. So I'm looking for, hey, no, no, no. Okay, we have the wrong p-value. Oh, it's D. Here we go. All right, next problem. We're looking at an SRS of 100 teachers, so hopefully we can look at this and say, hey, what do I need to do? And you had one similar to this on your quiz, but this was the correct answer here with E. All right. Also looking at this next one, trying to help you out. Here we go. We're looking at which one is correct, and we have a 95% confidence interval, which tells us that our Z critical needs to be 1.96. So cannot be, cannot be, cannot be. All right. And anytime we use combined standard deviations, we have to have addition. So B is the only one that it could possibly be. All right, just a different way of breaking down a multiple choice question. Here we go. We're looking to see between these two, okay, what's going on. Hopefully, when we calculate this, we get a p-value that is between. All right. Keep on moving on. Here we go. Hopefully these should be looking fairly similar, familiar, but let's just talk about this. Now this is a hypothesis test, so when we talk about standard error, we need to use p hat sub c, which is our combined, okay, p hat, which is x1 plus x2 over n1 plus n2, and in this case that's 0.706. So no, 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 okay. It has to be either B or C. And then let's look at what's the difference. Oh, once again, look at this. That is a no-no. We cannot have subtraction when we are combining standard deviations. B has to be my answer. Okay, number 6. Looking at a slightly different problem here for number 6. We're now moving on to some mean issues. All right. If we're looking at this, we see that we have our X bars and our standard deviations for the samples. So what do we have to do? If there's a significant difference, we want to find our t value, right? So we want to calculate t, and remember that would be our x bar sub 1 minus x bar sub 2 minus mu sub 1 mu sub 2, which of course hopefully we remember that's going to be 0, over the standard deviation, and we're going to take s sub x sub 1 squared over n1 plus, that's the key, plus sx sub 2 squared over n2. If we calculate correctly, hopefully we get 3.43 rounded, so that is C. All right, here we go. Number 7. We're looking. So we have n is greater than or equal to 30. All right. Because we have 62 divided up into two groups of 31 each, so our normality condition is met. We have random allocation because they are randomly divided by our experimenters, so this is met. And is it reasonable to assume independence in this situation? And that is true. Therefore, we're going to say none of the above. For number 8, looking at this mu sub d of high minus low is what we're talking about here. Which of the following is a correct interpretation of this interval? All right. So if it's an interval, we want no probability. So that means I want this out. Okay. I want this out. And I want this out because it, again, references probability. Then we're down to 98% of the intervals constructed in this way will contain the value 0. And B, we are 98% confident that this interval captures the true difference in mean heart rate of subjects like these who received the high step and low step treatments. B is rocking and rolling, okay? And we don't know what's going to be true for D, okay? Plus that would be more of an interpretation of our level. Remember the level? All right. Okay, so now we're still looking at number 8, and now we've set up our hypotheses. We think that it's going to be less than. We have a p-value. Which of the following is correct considering our alpha level is 0.05? So hopefully we're going to recognize that p is less than or equal to alpha, which means we should reject, right? And then it says interpretation of the result. So that means interpreting or interpret the p-value, which is how likely something is to occur given the null hypothesis is true. So, if the null hypothesis is true, the probability of getting a difference in sample means as far or farther from 0 as the difference in our samples is 0.0475. Sounds beautiful. That's D for our answer. And then let's look down here. Looking, and looking. All right, so we have a 98% confidence interval. Ooh. All right, so we have a confidence interval, so we're going to use inverse T and 1 plus confidence level over 2, comma, degrees of freedom, because, we're looking at something slightly different this time, because we do not usually use 98%. But if we calculate appropriately, hopefully we got a beautiful D and we're ready to rock and roll. You guys, please just take the time to review the differences between proportions and means so that you are prepared for your test. Peace out, statistics.